Welcome to Statics.
Example: three-dimensional moment. In this example problem, a metal plate lies in the xy plane. A force is directed from corner C of the plate to point B in space. I will find the moment the force causes about point A. Since our force vector and point A do not lie in any of the three coordinate system planes, I am going to use Cartesian vector notation. The first thing I'm going to do is identify the coordinates of points A, B, and C. I'll need that information to formulate my vectors, which is step number 2. Here's my basic moment equation. The moment vector is equal to a position vector cross the force vector. The position vector will originate at the point I'm finding my moment, and end at any point on the line of action of the force. I have two good options for my position vector. I can take it from A to B and cross it with F, or I can take it from A to C and cross that with F. Both of those will yield the exact same solution for the moment at A. Let's formulate the force and position vectors. I will start with the force vector by multiplying its magnitude by a unit vector in the direction of the force. The unit vector will be found by dividing a position vector in the direction of the force by its magnitude, which we can find using the coordinates of points C and B. The position vector is the difference between points C and B, and its magnitude is found using the Pythagorean theorem. Simplifying that, I get negative 40I, negative 20J, plus 40K newtons for force CB. Now let's get the position vector RAB. It is simply a position vector, so it is the difference between points B and A. Since point A is the origin, it is just the coordinates of point B. For academic purposes, I will also get the position vector RAC as the difference between points C and A. With the force vector and the position vector, I am now ready to perform the cross product. I will use position vector RAB and will put RAC aside for now. Now if I have a calculator that can perform the cross product function, I could just plug in these two vectors in the correct order R cross F and solve. But I will do it by hand. I put the vectors in this matrix form, with the position vector as the second row and the force vector as the third row, and find the determinant by taking the minors. First the I component, which will be 3 times 40 minus the product of 2 times negative 20. Then the J component, which is 1 times 40 minus the product of 2 times negative 40. Make sure to put a negative sign in front of the J component. Then the K component, which is 1 times negative 20 minus the product of 3 times negative 40. Simplifying each term, I get the moment vector at point A is 160I minus 120J plus 100K Newton meters. Now if I needed it, I could also find the magnitude and direction angles for the moment vector at point A. I use the Pythagorean theorem to get the magnitude. It is 224 Newton meters. I find the direction angles alpha, beta, and gamma the same way we have done before. For demonstration purposes, I could use the position vector RAC instead of RAB. While the numbers in our matrix are different, the resulting moment vector will be the same.